All right, are you ready? Here we go. 5.5, and we're looking at how to use inequalities in a triangle. Inequalities, remember that's like greater than or less than. That's what we're talking about with regard to inequality, and we want to use that within a triangle. Our essential question is, how can I find possible lengths of a triangle? Let's start with this basic theorem here that says that if one side of a triangle is longer than another side, then the angle opposite of the longer side is larger than the angle opposite of the shorter side. So the key word there is opposite. So what they're saying is, let's see, let's compare these two lengths here. This guy is 8, the other guy is 5. So which angle do you think, so 8 is greater than, right? 8 is greater than 5. Which angle do you think is greater than another angle? Which, can we say for sure is the case? And because this side is longer, or greater than 5, therefore the angle opposite of the larger side is larger than the angle that's opposite of the shorter or smaller side. So angle C is greater than angle A because angle C is opposite of the greater side and then A is. Okay? Or you can also say, and I guess you'd say a corollary to that would be that the largest angle is across from the largest or longest side. So across from or opposite, that is the key principle that we're looking at. And it does not matter what you start with. If you start with the largest angle, then you know opposite of that is going to be the largest side. Or if you start with the largest side, then you know across from that is going to be the largest angle. And the opposite is also true, that the shorter side is going to be across from the shorter angle. And so that's kind of what they're saying here in this diagram, that the shorter side is going to be across from the shorter angle. And what they're saying here in this theorem is that if you start with the angles, and here you are comparing two angles, so this angle is short or is smaller, say it that way. This angle is smaller than the 50-degree angle, and so the side opposite of that shorter or smaller angle is going to be the smaller side. So AB is smaller than BC. And let me also remind you what we mean by AB. When I say AB, that is just the two letters there together. If we had a bar on top of the AB, then you know that would be segment AB. Or if you had a bar with one arrow, that would be ray AB. Or if you had a bar with two arrows, that would be line AB. But when you just have AB by itself, that means the length of segment AB. So AB with a bar, that's a shape, segment AB. Just AB together, those two letters together, that is a number. That is the length of segment AB. So that's why we can compare numbers here. The length of segment AB is greater than the length of segment BC. So let's put that stuff to work. Here's an example from your textbook, and we see here that they give us all the angles. Now, first of all, remember these are, what kind of angles are these on the inside? What do we call those? Interior angles. And what is true about the interior angles of all triangles? The sum of the interior angles is 180 degrees. So if we were to add 46 plus 59 plus 75, we would get 180 degrees. But what we're looking at here is inequalities, comparison between angles and side lengths. So which angle is the smallest? This angle, 46, is the smallest angle. And so across from that angle always will be the smallest side. And that indeed is the case. Here's 20, 24, and 27. So this is the smallest side. We could also have started with the longest side. The longest side will always be across from the longest angle. So 27, in comparison to these other ones, is across from the angle that is the largest angle. Okay, so it doesn't matter where you start, but the comparison will always be true when you connect opposite angle and opposite side. So you are ready now to do the two problems that you have there in your notes. So number one, list the sides of triangle RST in order from shortest to longest. So how are you going to decide which of these sides is the shortest? And you can use these theorems here to tell you that. So list those three sides out in progression from shortest to longest, and then put the correct inequality symbol between those three. And then, yes, you can do this. Another stage prop is a right triangle. So I need you to draw me a right triangle over here. In fact, I'll go ahead and draw one for you. There you go. There is a right triangle. And now label it with these three lengths, and also these three angle measures, and make sure that they line up correctly so that the smallest side is across from the smallest angle, and the longest or largest side is across from the largest angle. Okay, so go ahead and pause the video and do those two. Now we're looking at the triangle inequality theorem, and what that tells us is that the sum of the lengths of any two sides of a triangle is greater, has to be, will always be greater than the length of the third side. In other words, I can take any two sides, like this pink and the blue, add those together, and it must be greater than the length of the third side. Or I can take the green and the blue and add those together, and they must be, that the sum of those two lengths must be greater than the third side. And same thing with the pink and the green. And why is that? Well, think about that. Here I have three sides, and in order to make a triangle, the sum of the two shorter sides, that's the key there, the sum of the two shorter sides has to be greater than the third side. Because if they are equal to, so let's say this guy over here is 5, the green is 5, and the orange is 2. If they are, take 5 plus 2 equals 7. So if this green, what am I saying, green, this red length is 7, then notice that these two other sides will not connect sufficiently to be able to create a triangle. The sum of the two smaller sides has to be greater than the third side. That's essentially what they are saying here, that the sum of two sides will always be greater than the length of the third side. So here's some problems for you. First of all, they want us to identify possible triangles. Is it possible to construct a triangle with the given side lengths? So if I gave you three side lengths of 6, 7, and 11, would you be able to create a triangle from those three sides? Remember, our principle here, our theorem, is that the sum of the two smaller sides has to be greater than, that's the key point, greater than the length of the third side. So let's take our two smaller sides, 6 plus 7, that has to be greater than 11 in order for it to be a triangle. Now I could also, using this theorem here, I could also say, well, it also has to be true for the other ones. 6 plus 11 has to be greater than 7, and 7 plus 11 has to be greater than 6. All I'm doing is just switching which pair of sides I'm adding together, and that has to be greater than the third side. And it is indeed the case. 6 plus 11, of course, is greater than 7 because 11 is greater than 7. 7 plus 11 is greater than 6, so I can put a yes beside that, and a yes beside that, obviously because 11 is greater than 7. So really the principle is that the sum of the two smaller sides has to be greater than the third side. So look for the two smaller sides, 6 plus 7, and that has to be greater than 11. So 6 plus 7 in this case is 13, if I have my math correct. And is 13 greater than 11? And the answer is yes. So therefore, yes, that will make a triangle, because the sum of the two smaller sides is greater than the length of the third side. So in other words, this guy is 7. Let's do it around this way. Pretend it this way. Okay, this guy is 6, and this guy is 7. And when we add them up, it is greater than this third side. So actually, it's not like it's drawn here, but these are long enough to be able to touch, because the sum of the two smaller are greater than the third. So you do the same thing. Do the same calculations with these other three sets of 3 sides, and see if you can make a triangle out of these lengths. Go ahead and pause the video and do that, please. And then lastly, possible side lengths. Describe the possible lengths of the third side of a triangle given the lengths of the other 2 sides. So all they're given to me now is just 2 lengths. I have 5 inches and 12 inches, and I have to figure out what is the range of length of sides that it could be, that I could have, and still be able to make a triangle. So there's 2 different scenarios here that we are concerned about. One is when, let's call x the unknown, the third side. One is when x is the shortest side. Well, hold on, let's do it this way. One where 12 is the longest side. That's the easiest way to say it. When 12 is the longest side, then we have a scenario like this. And when x is the longest side, then we have a scenario that looks kind of like this. And so in order for these 2 sides to touch, remember the sum of the 2 smaller sides has to be greater than the third side. So if 12 is the longest side, then x plus 5 has to be greater than 12. And then if x is the longest side, then 5 plus 12 has to be greater than x. Okay, so those are our 2 scenarios. One where 12 is the longest side, and one where x is the longest side. So let's go ahead and solve these inequalities. If I subtract 5 from both sides, then I have x is greater than 7. And on the other inequality, if I add 5 and 12, I get 17, and 17 has to be greater than x. And so now what I want to do is combine these together so that I can create a range that makes it easier for me to be able to see what are the possible lengths of x that will be necessary to make a triangle if I have 2 of the sides being 5 and 12. So what I do, take your smallest number and put that on the far left, and then put the x in the middle, and put your largest number on the right hand side. So again, I'm combining these 2 inequalities into this one composite inequality. And so you always have the smallest number on the left and the largest number on the right, and you have x here in the middle. And notice that, remember, think of it as a Pac-Man. So here is a Pac-Man. He always likes to eat the larger number. So when I switch these and put the 7 to the left, then that Pac-Man needs to continue to eat the larger number. So the Pac-Man's eating the X here. He needs to continue eating the X over here. So if I was to read it going left to right, it would be X is greater than 7. Or I can read it going right to left. 7 needs to be less than X. And that's what I have here, is that 7 is less than X. And do the same idea over here, that the Pac-Man is eating, the alligator is eating the 17. So when I switch it around to put it into a composite inequality, then I need to make sure that the Pac-Man is still eating the 17. So the way you would say this overall is that X has to be greater than 7. So I'm reading that backwards. Greater than 7, and also less than 17. So X has to be big enough so that when 12 is the longest side, that the X and the 5 touch together. But X has to be small enough so that when X is the smallest number, that 5 and 12 can touch together, and it'll still make a triangle. So go ahead and do number 22 and number 23. I know the numbering's messed up here, but it doesn't matter. But go ahead and do these. And I drew your templates here. And remember, let's do it where, take the largest number here, and let's make that the largest side. Or the other scenario is if X is the longest side. And then what would the other two sides be? And then make your inequalities from there, and then combine those two inequalities to create a composite inequality down here. Okay, hope that was helpful to you, and I look forward to seeing you in class.